Here's the dailyintegral.com easy integral from December 14th, 2025. It's the integral from 1/2 to root 3 over 2 x over the square root of 1 minus x squared dx. Now this is a great integral because you can actually do it two different ways. So I'm going to start by doing it with trig substitution, and then we'll look at it again with just a standard u substitution. So when you do a trig substitution, instead of letting u equal some function of x, we're going to let x equal a function of u. In fact, we're going to let x equal sine of u, or in this case, sine of theta. Then dx is cosine theta d theta. And if you draw a triangle, you can sort of see the relationship. So if sine of theta is x over 1, that means the opposite side is x, and the hypotenuse is 1, making that third side the square root of 1 minus x squared. So we get the integral from x equals 1/2 to x equals root 3 over 2. X is sine theta, so we get that in the top. In the denominator, you get the square root of 1 minus sine theta squared, and dx is just cosine theta d theta. But since sine squared theta plus cosine squared theta is equal to 1, the denominator is actually just cosine of theta, and those cosines cancel out. So you're left with just the integral of sine theta d theta, which is negative cosine theta. Using our right triangle, we see that cosine of theta is adjacent over hypotenuse, or just the square root of 1 minus x squared. And evaluating this from 1/2 to root 3 over 2, we end up with just the square root of 3 minus 1 over 2. The other way to do this problem is just with the standard u substitution. We let u equal 1 minus x squared. Du is going to be negative 2x dx. And if we change our bound, we see that u is going to start at 1 minus 1/2 squared, or 3/4, and then u is going to end at 1 minus root 3 over 2 squared, or 1/4. So we're going to get u goes from 3/4 to 1/4, negative 1/2, 1 over root u du. But because there's that negative there, we can actually change the bounds. We can switch the bounds to get rid of that negative sign, so we get the integral from 1/4 to 3/4 of just 1 over 2 root u du. But this is an integral we know. It's just root u evaluated from 1/4 to 3/4, so we get square root of 3 over 2 minus 1/2, which is the same answer we got when we did it the other way, which is nice that we get the same answer by doing the integral both different ways. That's how we're really sure that our answer is right. Very nice.